We're still in section 5.1 and we're still talking about the 11 fundamental identities, so I still have them up here on the board. But now we're going to see another reason or another way application of how we're going to use them. We've seen so far that you could take these identities and find the value of the 6 trig functions, doing it by an algebra concept of solving equations. The next way we're going to use trig identities, and this is the way we're going to use them more often, is we're going to use them to simplify expressions. Now, what does the word simplify mean? The word simplify means to get in lowest terms, to follow order of operations. So when you simplify 2 plus 3, it makes 5. When you simplify 4 divided by 2, it gets 2. When you simplify 3 squared, it gets 9. You follow order of operations. Simplify also means to make sure the answer is in lowest terms. So for example, do we write the fraction 2/4? No, because 2 over 4 means division, and both 2 and 4 can be divided by 2, and that would give you 1/2. So I want you to keep in mind, this next part, we are going to use these identities to simplify. Simplify means to get in lowest terms. In trig land, lowest terms means, number one, the answer is a monomial. Mono means one term. So when I say sine theta, that's a monomial, one term. When I say tangent theta, that answer is a monomial, one term. So when they say simplify to lowest terms, they want the answer to be a monomial. If the answer cannot be a monomial, then they want it in lowest terms. They mean in terms of sine and cosine, which means the answer shouldn't have tangents or cotangents or secants or cosecants. So this is pure algebra. We're going to be doing still substitution, replacing. But now instead of using numbers, we're going to be using terms, expressions. So for example, this expression 1 over secant theta is not in simplest form. It is not in lowest terms because it's a fraction. And we know in trig land, there's something that means the same thing as saying 1 over secant theta. Here's where you have to have your identities memorized. What expression means the same thing as saying 1 over secant theta? Well, here is 1 over secant theta, and it means the same thing as saying cosine theta. So any expression written as a fraction is not considered lowest terms. To make this lowest terms, we want it to be a monomial. And we know from our reciprocal identities, 1 over secant theta really means cosine theta. Now, there was no work there because that's a memorized fact, because you know this identity by heart. Okay, next. I have 1 minus cosine squared theta. This is my expression. This is not in simplest terms because there's 2 pieces. There's a 1 and a cosine squared theta. So this is not simplified. The goal is to see if we could rewrite this as one term, a monomial. Well, it's got a 1 in the square. So first of all, out of our 11 identities, where would we be looking? Very good. We would look at the Pythagoreans. They all have 1s in squares. Now, I'm not going to look here at cotangent and cosecant. I'm dealing with cosine. This is the identity that has cosine squared in it. We could take this because it is an equation and manipulate it, move the terms around. So let me write that. We know, we have memorized sine squared theta plus cosine squared theta equals 1. We have that memorized. How can we make this equation have 1 minus cosine squared together? We can move this cosine squared over to the right side by subtracting. Right, y'all? The cosine squared thetas would cancel, and that would leave us with sine squared theta on the left, and that would equal 1 minus cosine squared theta on the right. That means every time I see 1 minus cosine squared theta, I can replace it, substitute it for what it equals, which is sine squared theta. And if I replace 1 minus cosine squared theta with sine squared theta, I have now made this a monomial, one term, and that is simplified. So with the Pythagorean identities, because they are equations equals, you can manipulate, move the terms back and forth. All right, look at 5. I have a fraction, secant theta over cosecant theta. That is not in simplest form. Number one, it's a fraction, and number one, it doesn't have sines and cosines in it. So we're going to have to use our identities. Is there a straight identity that has secant over cosecant? Well, here are the reciprocals. Nope. Here are the ratios. No. So here we go. Here comes the fun. We're going to have to do a substitution. We're going to replace secant theta with something it equals. Well, if you look, secant theta is 1 over cosine. So in our numerator, we're going to rewrite this as 1 over cosine theta. Don't forget the theta. If you write 1 over cos, you're writing your trig wrong. What is cosecant theta equal? Well, according to our trig identities, the reciprocals, cosecant theta is 1 over sine theta. Everybody good? Now, you're going to say, well, Ms. Black, we just made more of a mess. This is worse looking than a minute ago. Almost. I agree. Now you made a fraction in the numerator and a fraction in the denominator. But what does the bar mean to do with fractions? It means to divide. And there's no such thing as dividing fractions, so you multiply by the reciprocal. So this expression is really the top fraction, 1 over cosine theta, times the reciprocal, which is sine theta over 1. Now we're going to multiply. Multiplying fractions is no problem. Top times top, bottom times bottom. So that would give me sine theta over cosine theta, and lo and behold, now you have an identity on your list. What does sine theta over cosine theta really represent in trig? Sine over cosine is a ratio identity, and it really represents tangent theta. And when you write tangent theta, that is one term, a monomial. That is simplified form. Simplified form means you can get the answer to be one term, a monomial. All right, look at 7. Secant theta times sine theta times cosecant theta. How are all these trig identities connected? That's right, multiplication. Now, again, what we want to do is we want to replace, substitute. It doesn't mean we have to replace all of them. In the world of trig, you want to leave, if there's a sine or cosine, you want to leave it alone. That's lowest terms. So I'm not going to do anything with the sine theta. I'm going to leave it. But what can I replace secant theta with? Well, again, according to reciprocals, secant is 1 over cosine. So I'm going to write 1 over cosine theta. I'm going to leave the sine theta. What can I represent cosecant theta with? Cosecant theta is 1 over sine theta. Okay, multiplying fractions is no problem. Top times top and bottom times bottom. But remember, in algebra, if this is connected by multiplication and these bars mean division, you can divide first. Who can divide out? Well, if I write sine as a fraction, we all know it's sine theta over 1, right? And now we have a sine theta in the numerator and a sine theta in the denominator, which will cancel out, which just leaves me with 1 times 1, which is 1, cosine theta times 1, which is cosine theta. Can I leave the answer like this? I know it has a cosine, which is lowest terms, but we know 1 over cosine stands for a monomial. 1 over cosine is secant. So this expression simplifies to that monomial secant theta. Now, is there a way to get this same answer without doing all this work? Sure there is. Let's talk a minute. What do you know about the relationship of sine and cosecant? Well, since the beginning of this course, we've talked. These guys are reciprocals. How are they connected? By what operation? Multiplication. So let's take this back to elementary school. What happens when you multiply numbers that are reciprocals? For example, I have a number 1/2, and I want to multiply it by its reciprocal 2. Well, that becomes 2 over 2, which is 1. You learned in elementary school, anytime you multiply a number times its reciprocal, the answer will always be 1. If that's true in arithmetic, that's true in algebra. You know in algebra, if I take x and I multiply it by its reciprocal, 1 over x, that gives me x over x, which is 1. So guys, we talk about this from the beginning of time. Arithmetic is an extension of algebra. What we do in algebra is arithmetic. What we do in trigonometry is arithmetic. So guys, if I'm asking you to multiply 2 trig functions that are reciprocals, you really don't need to show me any work. Because when you multiply reciprocals, what do they do to each other? They canceled out and gave me a 1. So I am perfectly okay with you circling this and saying, yo, Ms. Black, those are reciprocals. When I multiply reciprocals, that gives me a 1. And secant theta times 1 would just be the secant theta. Now remember, that only works if you multiply reciprocals. If you're adding reciprocals, they don't cancel out. It's only when you multiply. All right, so far so good. All right, let's go keep with our notes. Let's go to expression 9. So let me erase. All right, expression 9 says simplify. Tangent theta, then there's cotangent theta plus tangent theta. Okay. There's a quick way to do this, and there's not a quick way. Okay. This is a trigonomic expression. It's just like anything in algebra. You follow, please excuse my dear Aunt Sally. P means please do what's inside the grouping symbols first. E means do the exponent. M and D are multiply and divide in either order. A and S are add and subtract in either order. So if you look, you have tangent theta and you want to multiply it to cotangent theta plus tangent theta. So what operation is this? Addition. Can we add a cotangent to a tangent? Well, that would be like me asking you, can you add x to y? No, they're not alike. Okay, you know that. You could only add like terms. If I ask you to add tangent theta to tangent theta, you could do that. If I have a tangent theta and you had a tangent theta, we would have 2 tangent thetas because those are like. So we can't add these. We know something outside of parentheses means to distribute, right? So guys, you can distribute a trig function just like you can distribute a number. So we're going to multiply. So this is going to be written as tangent theta times cotangent theta plus tangent theta times another tangent theta. Do you all agree with that? So because I can't add what's in the inside because they're not alike, I'm going to distribute. Now, tangent theta and cotangent theta are what of each other? Very good. They are reciprocals. So the rule is, because we are multiplying reciprocals, what should the answer always be? 1. Make sense? Plus, tangent theta times tangent theta is like saying x times x. What's x times x till the day you die? It's x squared. So tangent theta times tangent theta is writing tangent squared theta. Remember, to show a square, they put it in the middle of the trig function and the angle. Now, you're not done simplifying because you have 2 terms. We're trying to get down to 1 term. So everybody look closely. What identity is that? Oh, it's got a 1 in the square. It must be a Pythagorean theorem. 1 plus tangent squared theta can be replaced with, substituted with, secant squared theta. Is that a monomial? Sure is. I simplified that expression. Isn't that neat? Awesome. All right, let's try another one. Let's go to 10 in your notes. Okay, example 10. Sine squared theta plus tangent squared theta plus cosine squared theta. All right. There is no identity up here right now that has all those 3 trig functions together. I'm asking you to simplify this. Get this in lowest terms. All right, guys, there's a lot of ways to approach this. But these all have squares on them, right? So the first place I should be looking is where? That's right, the Pythagoreans. Well, you would need a 1 plus a tangent squared to substitute. I don't have a 1 up there. Well, wait. I got sine squared, and if I add it to cosine squared, I know it's 1. Now, somebody's going to say to me, well, Miss Black, the sine squared is not being added to the cosine squared. All right, this is the hard part. You've got to realize everything we do in trig is related to arithmetic. If I wrote this on the board, 2 plus 3 plus 4, would you have to add those numbers in that order? Absolutely not. You could. You could say 2 plus 3 plus 4, and you would get 5 plus 4 is 9. But can't you rewrite this and say 2 plus 4 plus 3, and it mean the same thing? Yes, because back in arithmetic, you learn the commutative property of addition. Commute means go back and forth. And it doesn't matter what order you put numbers in to add. If that's true at numbers, that's true at letters. If you write in algebra x plus y, and I write in algebra y plus x, it means the same thing. So that's also true in trig. So is there a way we can rearrange these three terms to get an identity? Sure it is. If I had sine squared plus cosine squared, I would know what it equals. So I'm going to rearrange this. I'm going to write this as sine squared plus cosine squared plus tangent squared. And now I know. Right here is a Pythagorean identity. Because we know sine squared theta plus cosine squared theta can get replaced with 1. So these two expressions add to 1. So now we have 1 plus tangent squared theta, which if we still look at the Pythagorean identities, 1 plus tangent squared theta can get replaced, substituted with secant squared theta. And there's your answer as a monomial. So this is really hardcore algebra, thinking about your order of operations. Okay, let's try one more. Let's try 11. Okay, so 11 says, I want to do secant theta minus cosine theta. I want to simplify that. I can't subtract them right now because they're not like terms. You can only subtract a sine from a sine, a cosine from a cosine, just like you can only subtract an x from an x, a y from a y. All right, guys, so we got to make a substitution. I can replace secant theta with 1 over cosine theta. Do you agree? So that's my first move. I don't want to replace cosine theta. I want to leave that. Cosine and sine are lowest terms. But I'm going to write this as a fraction. Cosine theta over 1. Okay? So you never ever, when we're simplifying trig expressions, using our identities, we do not want to replace sines and cosines. That's lowest terms, unless we have to. All right, everybody look at me. What operation are we doing? Subtracting. When you subtract fractions, if you have something in the numerator that's the same as something in the denominator, can it divide out? Absolutely not. And that's where the boo-boos are going to be. The boo-boos are not going to be the trig. It's going to be the algebra skills. So let's go over here and take a walk down memory lane. There's a huge difference between me writing this in algebra and writing that in algebra. That is multiplying. Multiplying fractions is no problem. Top times top, bottom times bottom. Technically, you're supposed to go across and multiply. You get 2 in the numerator, 2 in the denominator, but then the bar means to divide, and you'd get 1. Because multiplication and division are equal operations, which means one is not better than the other. You can't say, please excuse my dear Aunt Sally, and say mom is more important than dad. Multiplying doesn't always go first and then go division. They're equal. You do them with whatever order you want. So by now, in trig, you should have been taught in algebra. If you're connected by multiplication and division, you could choose what to do first. And most people do the division first. 2 divided by 2 cancels out, and that leaves 1 over 1, which is 1. That is different than this expression. If I say a half minus 2, you are not allowed to divide here because that is not multiplication. And that's one of your biggest arithmetic rules. You only do division when you're connected by multiplication. That is not multiplication. So to subtract, you learned. Adding fractions, easy as can be. All you need is an LCD. You know to add and subtract, things have got to be alike. And in fraction land, the denominators are the part that have to be alike. So guys, we are subtracting. There is no canceling out these cosines, thetas. To subtract, I need a common denominator. What is the common denominator of cosine theta and 1? It is cosine theta. I love to sing, so I make songs up. So my song is, adding fractions easy as can be, all you need is an LCD. Now I know we're subtracting, but adding and subtracting go together. So I got my LCD. The rule is, if you change the denominator, you must change the numerator. Think about this. If I was asking you to subtract here, you'd get a common denominator, which is 2. This numerator would stay 1 because the denominator is already 2. This denominator is the one you changed. You made a 1 become a 2 by timesing by 2. So that means in the numerator, 2 times 2 would be 4. So only if you change the denominator do you change the numerator. So back to trig. The denominator was cosine theta. That can stay a 1. I had to change that by multiplying by cosine theta. So in the numerator, cosine theta times cosine theta would be cosine squared theta. Now, the whole purpose of making a common denominator is to subtract. So when you subtract and add fractions, you work with the numerator. 1 minus 4 is negative 3. The denominator stays the same, 2. Correct? Same thing here. We're subtracting. We keep the denominator. We subtract the numerator. 1 minus cosine squared theta we write as 1 minus cosine squared theta. So my song goes, adding fractions easy as can be, all you need is an LCD. I look, I don't have a denominator. That's the same. So I make it the same. If I change the denominator, I must change the numerator. I change that denominator, therefore I change that numerator. Write the bottom, collect the top, reduce the fraction, then you stop. I wrote the bottom, I put together the top. Now we're not done, we're going to reduce this. Now that it's one fraction, everybody look what's in the numerator. 1 minus cosine squared theta. What can 1 minus cosine squared theta get replaced with? Well, that's a Pythagorean. Here's the Pythagorean right here. If I move this cosine to the right side, it would become a minus, and it would equal sine squared. So now I could replace this numerator, reduce it, with sine squared theta. Now that's not simplified. And let me explain why. It's still a fraction. They really want to see monomials. One term, one term. So you're going to say, what do I do? Well, what does sine squared mean? Sine squared means sine theta times sine theta, right? And this is a cosine theta. How many cosine thetas are in the denominator? Well, there's just one. So this would be cosine theta, only one of them. Well, what happens if you write it like that? Sine over cosine. What does sine over cosine stand for? According to the ratio identities, sine over cosine can get replaced, substituted for tangent. So now that becomes tangent theta, which is a monomial, and that just stays good old sine theta, which is a monomial. And because those two are side by side, connected by multiplication, that's what a monomial is. Now I know what you're saying, that's not a monomial. Yes, it is. In algebra, if you write AB, that's connected by multiplication, that's one term, a monomial. So that is simplified. Even though it's just not one trig function, because they're connected by multiplication, it is considered a monomial. So this is the beginning of a really tough chapter, because now you've seen to work with these trig identities, you're recalling your algebra skills. And your algebra skills means you're recalling your arithmetic skills. You've got to be neat, you've got to be organized, you really got to pay attention. In the next section we do, we're going to learn to balance, to prove that we are correct by doing our simplification. I'll see you in section 5-2.